Stand on one side of certain mountain ranges, and the land is green and lush. Walk over the ridge to the other side, and it's suddenly bone dry. Same mountain, same latitude, two completely different worlds. And it goes further than you'd think. Because a desert was never really about heat. A desert is defined by how little rain falls, not by temperature, which is why Antarctica, cold as it is, technically counts as the largest desert on Earth. So what actually starves a place of rain? Sometimes it's the mountain itself. Moist air gets forced up and over a mountain range, cooling as it climbs and dropping nearly all its rain on the near side. By the time that air spills down the far slope, there's almost nothing left to fall. That's a rain shadow. But mountains aren't the only rain-blocking mechanism at work. Remember that band of sinking, drying air around 30 degrees north and south of the equator, driven by the same Hadley cell circulation that shapes climate zones worldwide? That exact belt is why the Sahara, the Arabian desert, and Australia's Outback all sit at roughly the same latitude. It's not a coincidence. It's the same global air circulation pattern showing up on 3 different continents. Rain shadows and Hadley cell subsidence, 2 completely different mechanisms producing the same dry result. Push a little further, and deserts turn out to be far from static. Desert boundaries expand and contract over time, driven partly by shifting climate and partly by how land gets used, especially over grazing and irrigation practices that strip away the vegetation holding soil in place. And deserts hold an extreme record most people don't expect. They own both ends of it, the hottest temperature ever reliably recorded on Earth, and, in Antarctica's dry valleys, some of the coldest and driest ground on the entire planet. So the next time you cross from a green landscape into a dry one, remember, you're not just crossing a border, you're crossing whatever mechanism decided rain wasn't allowed to reach this side.